Um, okay, is anybody going to present today? No? Okay, so please, there's 35 people in the class, only two people presented so far. I forgot to give them their grade. I'm gonna give it tonight, hopefully. Um, okay, so please, and also the people present, you can see whatever, the people, the earlier you present, the better you score also in general. Uh, okay, so what are we doing? So today, let's do a quick review of what we did last class and then we'll go. Okay, so uh, this is Drive. Sorry. Yeah, stuck in my throat. Have a drink here. This is bullshit. There we go. Okay, so last class we started discussing um, we began with we already did the first four object-oriented principles. Does anybody remember what they are? The first four? The basic four?
Number two,
Okay,
polymorphism, encapsulation, inheritance.
yeah, abstraction.
Trash.
There you go. Okay. Do you know what they mean? What do they mean? Inheritance means to,
Inheritance means you can pretty much take things from the higher class. Um,
reuse code.
use the
Yeah, that's a two-word.
encapsulation means you can hide what the actual thing does and then just.
You could protect data.
Polymorphism means you can uh, add one to a function, meaning like
Say again?
polymorphism add on to a function, meaning that you can put this, for example, add an extra.
Parameter, right,
It's
right, right. Yeah, and what's the fourth one? Abstraction, that's the easiest one. It sounds the most complicated. Abstraction means when you provide a method, so that means you're doing something that somebody outside that class doesn't need to know how to do. So basically, you're abstracting that concept for me. No, everybody outside that class, right? This idea how to do something is now abstract. So, okay. Um, yes, that's actually the easiest one. Okay. And then we spoke about the different ways the objects could relate to each other. So we did the is a, which is we said is, um, for example, is inheritance is inheritance is a relationship. Then we spoke about has a, which means that like basically composition, where let's say one object could contain other objects. And then we spoke about there's also another way two objects could speak to each other is or commonly used, right? Is if one object is passed as a parameter, right? So it's not inside me, but it's passed to me, right? Um, and then the last way we said was like through messages, like over the internet, right? There's a bunch of messages going back and forth, and that's how objects communicate with each other. And I don't know any other ways. If you know them, let me know. I don't think I don't know. I'm not sure what else there might be. Um, okay, so those are the four ways. But today we're discussing the inheritance. And um, we spoke about that we have like three basic problems with inheritance. Okay, what are they? So the first problem is that inheritance, if I want to use something inside another object, if I inherit from that object, I get more than I want necessarily want. But I just want one little thing. I want to know how to, like in our case, I wanted the flying functionality. But in order to get that from another duck, for example, I had to inherit from it. And then I got everything that came with it, the way it made noise, the way it flies, everything that I got too much, right? And all I wanted was just a little part of it, but I'm not allowed to do that. Okay. And then the second problem is, okay, that's the major problem, okay? Number one is the major problem of inheritance is that it's giving more than you want, more than you necessarily want. And then when you don't want it, you want to do, notice when the parent object does some things that you don't want to do, you have to like fight against it, right? So like you're fighting with yourself, basically. You end up fighting with yourself. In other words, let's say someone's inherits, let's say a duck inherits flying be somebody wants to inherit the quack behavior, but along with the quack behavior, they're getting the flying behavior. And then in order to undo that, you have to write your own flying behavior or to counteract it. Or you have to like get rid of it by having an empty method that doesn't do any flying. So you have to somehow, so it ends up, it's a very strong relationship and it causes, and basically the idea is I'm getting too much, more than I want. And also, okay. And then with inheritance, um, at least in Java, you can only inherit from one object at a time. And because of that, if you want, let's say, there's something from two objects, you're sort of stuck, right? You can't inherit from two things, you can only inherit from one. So there's no way that I could get from both, from you just using inheritance, there's no way to get to get something from two different objects. Okay, but see over here though, when I used over here, see class DD, it's actually it's able to reuse um, A, B, and C. It's able to use all three at the same time. And because it's not doing inheritance, what's it doing? Remember we said this is called? This is called composition, right? Because it's by using composition, class DD is able to use A, B, or C, right? See over here, it's using A, B, and C at the same time. So by using composition, you get rid of that this uh, um, restriction that inheritance has, at least in Java. Okay, so I could just use A, B, or C. So whatever is inside of me, I could use it. And then the last thing is, okay, everything so far good? Any questions? Let me just see if I could make sure people at home could say something. Wait a minute, I gotta do voice. Oh, I know if I have to do it here. Uh, on the Zoom. I do audio. I do, uh, well, I don't have Adele, so it's probably this one. Okay, I hope, so anybody want to say something? Oh, I'm not sharing the screen? I thought it was. I think I was. Yeah, I think it was. Anyhow, so, what, um, um, so, okay, so where are we up to? Oh, yeah, so the last thing, um, um, oh, could somebody at home say something? Just want to hear if we can hear you.
Hello?
Hey, great. Everybody heard you. Okay, great. It was a great hello. Okay, so then we have number three. Thank you so much, by the way. The number three we have is the third problem with a inheritance is that in general, where everything becomes very dependent on the parent, and someone accidentally changes the parent, they're going to, it's hard to understand what effect it's going to have on all the, you could have grandchildren and children, and all over the place. So it's hard to understand what the effects are going to be, right? So in general, like where I work, we're very nervous about changing parent classes because we don't know the effect that's going to happen, right? Uh, so in general, it's not too good. So basically, what did I write? Did I write? This one. Yeah. Okay. So what is the alternative? How could we reuse code, right? But at the same time, um, not do inheritance, right? That's the question. So is there a solution is there another way of doing things besides inheritance? So we're going to look at today is the strategy pattern, okay? So um, we're going to take a fresh look at our duck example from last week, and we're going to do it a little bit different way, okay? Okay, so if you have any questions, ask me because I'm be using a little bit of Java that you might not be familiar with. No, 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 not too complicated. Okay, so let's just do new project, and we're going to do strategy pattern for a 2025. Okay, so so what we're going to do now is we'll again start with our duck. I don't know what this thing is doing. Okay, so we'll start with, can everybody see it? By the way, should I turn off the light? Would that be better? Yeah, maybe turn off the light. Sure. Yeah, that better? I think it's much better, right?
Yes.
Okay, so, um, okay, so over here, we're gonna add a new object called duck, okay? Just like we had before. And now the thing is, before we had the fly behavior as a method here, right? That was the old way, right? The old way was we had a void fly, and this is a something like that. That wasn't good. Something like this, you know, uh, fly. Right. So now but the problem is we said that um, that's going to cause problems when you do inheritance. So what we want to do is we want to get away from inheritance. And instead, we're going to do something else. We're going to do something called does anybody know are you familiar with an interface? Okay. Does anybody know what an interface is? An interface is basically, I forgot what they're called um, I think there's a different name in other languages. Maybe you could correct me. Um, like an interface is basically like a contract. It's like an advertisement. That's how I think of it. In other words, like a interface means that, like for example, let's say you go to the airport and you see somebody walking, um, you're walking in the airport and they have like a pilot cap and they have like these bars on their shoulders, right? So what do you assume? You assume that they're a pilot, right? Right? So, but do you really know they're a pilot? No, but they're dressed up like a pilot. So they're advertising that they have the capability to fly an airplane, right? is like any type of uniform, right? Let's say a fireman has a red hat, right? Walks in with the whole fireman thing. So you assume that they have the capability to put out a fire. Or somebody wears a white coat, you assume they're a doc in a stethoscope, you assume, oh, they're a doctor, they could heal people, right? How do you know? Because that's what their clothes are advertising. So an interface is an advertisement what a class could do, what an object could do. So for example, let's do an interface, a very simple interface called fly. And so this is going to advertise, uh, shift capital, right? Because that's the Java standard. And what this fly interface has is one method called fly. And there's no code, right? It's just so the fly interface is advertising that if you what's called implement me, then that means you have to be able to fly. So I'm advertising the capability to fly. And let's do one more capability. Let's say quick. So um, let's do quick. And we're going to have the ability to, again, there's going to be no code because we're not actually doing anything. These are just the abilities that come along with this interface. Okay. So now, void, oops, okay. So now, I'm doing the wrong thing. What's wrong? Oh, it's interface. Nice. Clicked the wrong thing. Okay. So, so now going back to our duck, we're going to say that our duck has a fly interface. It has within it has this is remember in Java it's called a reference. So it has a reference to a fly uh, to some object that flies, right? And as a reference to some object that quacks. Okay. So when we create the duck, we're going to do is we're going to pass in, um, let's do the constructor. Okay, so it's going to pass in, when we create this duck, we're going to give it an object that has it could be the same object or it could be a different object, but we're passing an object that advertises itself that it knows how to fly, and an object that advertises itself that knows how to quack. So, so it could be actually pretty much, we'll see, could be a lot of different things. So then when a duck flies, it's not really flying on its own. What it's doing is it's using the behavior that was passed into it. So we make a method here called fly. We could have uh, uh, fly dot fly, and same thing for quack. We could have quack dot quack. So let's see what's going on here. So just to review, I know we're gonna do a lot of this, so you're gonna get used to it. Um, but it's really cool when it works. Uh, quick. Okay, so basically what we have now is we have an object which is when it's created is passed in two objects. One object which advertises that it knows how to fly. Another object that advertises that it knows how to quack. And then when the duck flies or quacks, the duck says, I don't know anything about what I'm doing, about flying or quacking, but whatever behavior you gave me, that's what I'm going to do. So the idea is that the duck now doesn't, it flies and it quacks, but the way it does it is the way that was passed into it, right? So let's see an example. So let's actually create a class that let's do a regular um, regular flying, a regular flying. So this is going to implement the implement the I the uh, blah, oh implements, sorry, implements um what is that? Implements flying. Okay, so what happened? Oh, this thing's in the way. I can't see what's going on. That's what. Okay, so this is implements fly. Now we'll look what happens. Once I say that regular flying is going to do the fly thing, right? You notice right away I get this red line. Why do I get that red line? Because because if you say you could do something, then you have to do it. So if I'm claiming that I have this I have the that I'm going to do this fly I'm going to implement this fly interface, then I need a method called fly because that's what this interface means. Interface means that when you advertise that that you perform the fly interface, that means you have to have a fly method. So over here, I have to create a see Java even knows and actually will just create it for me. So now I have a fly method within my my regular fly, right? Because I implement fly, I have to be able to fly, and let's just do, I'll just say regular fly. Okay, regular. And let's do the same idea for quack. So let's do regular quacking. So we'll do regular quacking. And we're going to implement the quack interface. And it's going to give us an error because we have to give it a quack, right? So we'll give it this and then we'll just say S out regular quacking. And just to let's just make one more just for the fun of it. We could do um, let's say no quacking, no quack, and this implements the quack um, interface. Yeah, and then we have to obviously create the verb for it, the quack, and this will be uh, I don't quack. Okay, and then now what I'm going to do is let's just put it together and look it over. Okay, so going to main, we're going to create a duck. No, okay, let's create a duck. So we want to do a duck equals to new duck. Now we have a problem here because we need two parameters, right? We need a object that implements flying and an object that does quacking. So we could do is we could pass in um, pass in new regular flying, and we could pass in new regular quacking. Then we could go and we could say duck dot fly and duck dot quack. And we could um, then we could do like this. We could say change what duck is pointing to, and we could give it a different object called no quack. And uh, let's see what happens when we do this. So, oh, I have to hide that. Uh, okay, so look what we did. We basically we didn't change duck at all, right? But instead we just passed in different behavior, right? And by doing that, right, what do we accomplish? We accomplished that. Well, let's run it. Okay, let's see what we accomplished. Um, so first, when we do the duck, the first object of duck is going to, okay, think it, how to get this thing to disappear. So he's going somewhere. Okay, so first it's doing regular flying and regular quacking. Then the second object of duck, it's not quacking, right? So we basically what we can do is we're basically we could pass in the behavior that we want, and the object itself is going to stay the same. So you don't have to inherit from another object, but rather we're just passing in that piece of code that the person wants. Um, Now we could also do something like this. We could do this is a little bit crazy, but we could do this. We could do let's say we could do um, um, uh, let's say we have it's a crazy example, but I just want to show you that we could do it. So we could do a airplane which implements fly, and then uh, the airplane could be uh, flying at 20, I don't know, 30,000 feet. I don't know how high they go. 30,000 feet. And then we could actually go back to over here and we could pass in an airplane. It's a little bit crazy, but since the airplane implements the flying behavior, it says airplane says, what does the airplane say? I implement the fly interface, which means that I guarantee you that I have this fly method. So even though it has, let's say, a million other things, like it might have landing wheels or let's say string, uh, it might have, oh, capital S in Java. It might have um, let's say landing wheels or some other stuff, right? What else would play in Windows? Right, so even though it might have these things, oh, actually, Uh, could I do that? Yeah, I could do it. That's cool. I could do that. Okay, so I could do that. Okay, so I have so even though um, the airplane is obviously not a duck, right? But still, I'm sorry, I can't see what I'm doing. Uh, Here we go. So, but still in Maine, I could pass in the airplane to the duck object because the duck object is only going to take the flying behavior part of airplane. Isn't that cool? So remember we had the problem with inheritance of just taking what I want? Well, if you have an interface for this object, then duck is only going to use that part of the object which it's specified, which is fly. Okay? That's really cool. So if we go over here, we could have a duck using the flying behavior of an airplane, even though it's not obviously not an airplane. So if we run this, yeah, so right, you see it's using the flying behavior of an airplane, which says it's flying at 30,000 feet. So, so right, so we see, okay, so we see a bunch of things. Where is that? Oops. No, no. You don't want to see that. Uh, da, da. Okay, no, that's not. I forgot how to use this preview thing. There's a way to stop. Oh, video mute. Anyhow, whatever. Um, oh, so where was that? Document. So, so going back here. Okay, so basically, there's a couple things. Number one is we have a new um, we actually have two. Um, wait, so one is, um, wait, what's the second one? Uh, oh, okay. Yeah, wait, so one of them is, well, let's do the first one. The first object-oriented, so this is number five. So now we have object-oriented principle. We already did the first four to that right before. So number five is going to be prefer composition to inheritance, right? So if we don't use inheritance to share code, it's better to use composition, right? So we see this from the duck, right? And then um, the other one um, is that what's it? Um, I'm not sure if okay, well we see it. Um, another thing that we see from the duck is that I hope I'm not skipping one. Number six is going to be that that the code should be open for extension, closed for modification as much as possible, obviously. So basically, look what happened to the with this code over here with the duck. Over here, we have three different types of behavior for a duck, right? But we have three different like animals, right? We have, one type of duck, and you have another type of duck over here, a third type of duck over here. And we didn't change any of the actual duck code, right? Because all the duck did was whatever behavior we passed in, right? That's what it did. So, right, because so we passed in, airplane flying, so it flew like an airplane, right? So but because of that, we didn't have to change the duck object, right? So, so this principle is known as, where's my word? Oh, it's online, that's why. Oh, okay. So this is known as open for extension, closed for modification. Okay? Because we're able to add more behavior, we could change things, but we don't have to, we don't, um, but even when we're changing, we're not breaking anything, right? In other words, Um, this is actually known as the open-close principle. So, um, so basically means we're uh, open-close principle. So means that we're open for extension, meaning that, meaning that um, we um, add new behavior by adding code, not but I mean, we change. I shouldn't say add new behavior, or we change behavior by adding new objects, not by changing existing code, right? Okay, obviously, real life is never going to be so nice as this, but if you look over here, but you see how nice it is that it's that to change the behavior of the duck, we're not changing duck. In fact, and when we're adding new types of flying, we're not. Oh, okay. So we see there we're right. So over here we're just creating more types of flying, right? I didn't have to change anything, right? When I added airplane flying, did I change did I modify any of the other classes? No, I just had to add it to main, but I didn't modify anything else, right? And the biggest, right, the biggest source of bugs is when code is changed, right? Slash modify. So we want to try to avoid that as much as possible. Right? We rather add code than modify code because if you think about it, if a program is working, there's only one way it could break if you change the code, right? So we want to add because, and also, by the way, if you have code that's really tested well, so then if you're adding code, you don't have to retest the old code, right? Because how it's impossible to break the old code, right? Because it's just new code that we're doing. So it's always good to do this open close principle, okay? Um, Another thing is um, um, it, oh, okay. Um, okay, now let's talk about the duck. So there's something called, I'm going to teach you a really fancy word, okay? Dependency injection, okay? So the idea is that, the duck needs something that flies and something that quacks, right? So we basically, we passed into it, we injected the behavior into the duck. That's what dependency injection means, that you pass into an object the things that it needs. Rather than changing it, we inject it into it. That's another way of saying it, right? So it's another way of saying, um, wait a second, it's another way of saying, well, okay, I shouldn't say it another way. That's what we did. Okay. What, okay, so you'll hear about this word dependency injection, where we pass into an object those things uh, that it is dependent, that it dependent or needs, right? On, okay. And then usually what we pass in, it will cause the object to behave in a different way. Okay, which brings us, I spelled dependent wrong. Dependent. What just happened? Uh, what just happened? Uh, what did I just? Oh, here. Uh, okay, dependent. Okay. Um, okay. Now we're gonna come to first um, our first design pattern. So which is basically what we just did. So design pattern one is going to be the strategy pattern. And basically, basically the idea is to uh, place those, they call it behaviors, but it's a little bit weird when you call it behaviors. But basically, the parts that change, put that into a different object and pass it in. That's the idea of the strategy pattern. So place those behaviors, they call it, but I'll just use their word, that change and place into their own object and pass them in. The object and the, okay, like I'll do a really quick, another quick example of of the strategy pattern. Let's say, for example, um, let me just do, I'll do really quick. So let's say, for example, I have uh, let's say a accounting package, right? And I don't know, let's call it my accounting package, package. And what I want to do is I want to, um, let's say, I have a method called uh, calculate taxes for this year. Okay. So one way you might do it is you might pass in for Notice without this pattern, without the strategy pattern, right, you might do like this. You might say, well, I'm trying to get this thing out of the way. It's so annoying. So what does this do? No, that's already. Uh, okay. So one thing you might say is you might pass in the year. So int year, and then you'll say if year equals to, let's say 2024, then, you know, calculate one way, right? And then you'll say, and then else uh, if year equals to 2025, then um, you know, calculate a different way. So this is one way of doing this. What did I do wrong?
Nobody saw.
Oh, okay, right. Thanks. Okay, so this is the other way of doing it. This is like the way probably most people would do it, right? So what's wrong with this? Because remember our principle, we want to be open for extension, closed for modification. So what's going to happen is, what's going to happen next year? We're going to have to add a new if statement, right? Right? What?
You have to keep adding, right?
Right. But basically, we're modifying the code every year, right? I mean, this is a simple example, but but you get the idea that when you're using if statements, then after a while it gets very complicated and a lot of things could go wrong. Like a lot of people like to use if statements and and after a while it's gonna come back to bite you because it gets so complicated. Like usually it's not just one statement. It's usually if year equals 2024 and you live in the state and this and that. And they get very complicated. And then you have a whole bunch of them together. It gets really complicated. And you're not um, you're whatever. You're over a certain age or under a certain age. So when you use if statements, it's going to be very complicated after a while. So even though this is probably kind of hard to mess up, but the idea is that we're modifying the code every year, right? So better way to do it. Oh boy. Um, I can't do. Sorry about that. So, uh, and so another way to do this would be let's get rid of this way of doing it, and I'll just comment this out. And instead, we're going to have just like we had before, is we're going to have um, we'll have an interface called calculate. Calculate. Um, the reason why I'm typing slow is because I can't see the keyboard. Calculate tax, and this is a interface. And we're going to do the exact same thing we did before, and we're going to have a void calculate. So that's all we do is we calculate. I'm not doing good today. And then we're going to make this a member of the My Accounting package, right? We put over here, and we're going to, and then in the construct, I think my battery is a little low, and then within the constructor, I'm going to pass in this, and then And then when I calculate the tax, I'm going to, I'll just, I'll just call calculate. And, oh boy, that was a bad spelling. And then I'll void, make it public. And then I'll just call the calculate tax dot calculate. So whatever that does, so basically every year I just make another object which implements calculate tax. So I could have an object called uh, calculate um, 2025 the tax. I can have another one which implements um, calculate tax. And then so I have to do a calculate method. And then I could have the same idea. I could have calculate cal just copy this to 2024. Let me hide that. Must be a setting to never show that thing. So I could just calculate 2024 tax, and then also implements calculate tax, and then it has its own method. Okay, so then in main, I would have the same thing, right? In main, I would have um, my accounting package um, equals to new my accounting package, and then I would pass in, let's say, new, um, let's say for 2025, and then I would call um, I forgot to put a semicolon there, and then I would just call. Okay, so here this is like, so this way, I'm not changing my accounting package, right? I'm just creating every tax year. I just create another object which I pass into it. So the idea of the strategy pattern is, like we said over here, is to see what changes and place them into their own object, and then pass those objects into the object underneath it. Okay, so that's exactly what we did with the duck, and we just did it um, with the tax, right? Actually, when I first learned this design pattern, I learned it with taxes, I think. Then I saw then there's the duck pattern, which is more famous. Um, and okay, so that's design pattern one. Uh, so any questions? Or is it pretty pretty clear what uh, what it is. So the strategy pattern again is you want to take the behaviors and put them into their own right. So then it so and it does and it also implements, right, these uh, two object-oriented principles, which is, remember what they are? One is open closed, right? Open closed principle, right? Because we're passing in the dependencies, right? And the second thing is we're we're using composition rather than inheritance. We prefer, we don't like inheritance to inherit. It took a number of years before they figured this out, but but these are the two principles that we put over here, right? So, 5 and 6. Okay, I'll just put them together. Okay. Um, okay. Um, so what do we do next? Um, let's see. I think we should take a break from programming. So I was going to do another design pattern, but I think it's probably better we wait, give it a break. So let's move on to chapter 2. Okay. So let me just turn the light. Okay. So so I'll just move back. Yeah. I like, mixing it up. So now we're gonna go to chapter 2 of the book. Okay. Okay, so today this is what we did today. Um, which we did a lot. Okay. Um, so now I'd like to do is the chapter 2 of the book. Um, well, at least we'll start it, okay? So so basically, when somebody has a problem to solve, there's really two different ways to solve it, right? So let's say you have to write a book report. So some people will, like I know there's one author, when he writes a book, he before he starts writing the book, he has everything, he knows everything. It's crazy. He writes like a 300-page book. He knows everything that's going to happen in the book before he writes it, right? He like is right. He has a lot of patience, goes over it, figures it all out, the plot and all that before he writes anything. So, so that's one way of doing it. But I think most people will just start writing, and then they go back and they scratch, erase stuff, or tear it up or delete it, and then they change it as they go, and they keep going back and forth, and that's how they do it. Okay. So there's actually when you when it used to be, I think before the year 2000, there was only one way that things were done, and that was that everything was planned ahead of time. This is called the waterfall model. Now, the reason why it's called waterfall is, let's look at a waterfall, right? A waterfall model, uh, waterfall, um, it's called SDLC, which is software development lifecycle. So let's do an image. I don't want to do that. So let's do a nice little image. Um, this is not clear. Okay, so basically, it it looks like a waterfall, and the reason why it's a waterfall is because remember we said the idea is that you do all the everything up front, right? So the idea of a waterfall in software engineering is to um, is to do the goal is do everything just one time. And you might say, well, that sounds kind of crazy, right? What, I mean, it makes it really hard to imagine trying to think of everything that the software is going to need. Like, it's really hard until you start, it's really hard to think about it. Um, and then, so you would do the requirements. Remember, we spoke about what are requirements? Requirements are what the user asks for. So we get all that through, right? We figure out what the program has to do, and then we would go on to the design. And the reason why it's called a waterfall is because what happens to a waterfall? The water goes down, but never goes up, right? Because we only want it to go down. We don't want to go back up. Okay, so we want to do every step, and after we do requirements, we fire the requirement people because it's done. We do design of the software, then we fire those people. We don't need them anymore. They could do a different project. Then we start writing the code, then then the programmers can move on to another project. Then we test it, then we deploy it, and then we do maintenance. So all these things are are all only once. Okay? That's the goal. The goal is not to keep on changing the requirements and um, keep on changing all the different parts of it, but rather get everything figured out before we start designing it. So we only design once, we only do development once. So in some ways, it sounds like now that I'm thinking about it, I mean, in a way, it sounds crazy because I don't do things like that, but I guess it does have a certain simplicity to it, right? So a lot of people used to. I'm sorry, I think nearly all big companies basically used to do this. They used to get the requirements, design, and all that. And the reason why the problem with waterfall is that it failed. That's the big problem. And the reason why it failed, or projects kept on failing, and we're talking about a lot of money, right? People spend years and years on requirements, design, and then they fell too far behind schedule. And the reason is because if you look at this waterfall, the development is only done like in this example at the third step, right? But so basically, let's say you have 3 years for a project. So you say, okay, we're going to do 1 year requirements, 1 year design, 1 year development. But that means that you haven't done any development until the third year, right? So that means if something unexpected happens, which always does, then there goes your deadline, right? Because you put yourself into um, like you boxed yourself in because the first year you already gave up for requirements, the second year you gave up for design, and now you're stuck in development, and development always takes longer than you expect, right? I used to have a boss, he would ask me, how long do you think it takes? I say, oh, I'm sure I could do it in a week. So he says, okay, 2 weeks. So whatever whatever I would say, he would double it because it's always more than you think it will take, right? Anytime you're doing something new, right? Where you look at every Pentagon defense contract, right? Right, they're always years behind and billions of dollars over what they, right? Look at the World Trade Center. They built it. It took them 11 years to build it, right? Because they started building it, and then I think they changed something with the subway underneath it, and I think they weren't going to have a subway station, and they decided they had to have it. I don't know, whatever. It took like 11 years, a very long time. I mean, regular. It was. I mean, it was built by the Port Authority. That sort of figure. Yeah, it wasn't built by a private person would not have had the money for 11 years worth of to build one building, right? Um, so that's the problem with waterfall. It sounds like nice, we got everything out of the way, we got this out of the way. Now we're going to do that, but the problem is that you're only starting the development in the last time remaining. And then of course there's also testing and deployment. So, but the big thing is the development though. That takes the most time, and development always takes more than you think, and there's no wiggle room anymore, right? Because you already finished the requirements, you already finished the design. So there's no wiggle room. You can't change the requirements because if you do, then you have to go all the way back, and it gets very messy. So that's why after the year 2000 around, they started what's called the incremental pattern. Remember I said there's two ways people approach problems. One way is they figure everything up front. Well, the second way is the incremental pattern, and the incremental pattern is that let's see if we have a nice little picture here. incremental uh, SDLC again stands for Software Development Lifecycle, a model. And let's do an image of that. Okay, so here's an example over here. So over here, we're basically, it's a little bit different actually. Well, okay, so over here, what we're doing is we're having a bunch of increments, meaning this is not clear. Let me find a little bit. Uh, okay, there's a little bit more. Could you see this? It's a little bit, the color's not so great. So basically, it shows that we go from one to the other. We go from requirements, design, implementation, testing, deployment. No, that's maintenance? What? No, that something's wrong with that one. Let me find a nice one. Okay, this is, could you read this one? I think this is a little, okay, so this is basically saying that every time we go through it, we're gonna do a little bit design. Like we start out, we do a little bit of everything. So we're doing a little bit of design. Well, the truth is the requirements could also change. So it's a little bit different. So we're doing a little bit of, let me find one that's like our book. Okay, this would be it. Okay, so over here, we do requirements, analysis, design, coding, and then we're done with increment one. Then we start again. What did I just click? Uh, I just clicked something I didn't want to. I just had it. Okay, but the basic idea is that we basically let's say every month, every 2 months, we're going to do a little bit of everything. And the point is that since we're doing a little bit of everything, right? We're doing a little bit requirements, a little bit design, a little bit code, a little bit testing. So we know we get after a while, we get an idea how long things are going to take. Okay? Because because we're actually doing everything, right? Remember, what was the problem with the waterfall? We didn't do any coding to the end, right? And then we were stuck in a jam, right? We had a time crunch. We had only 1 year left to finish the project, right? But over here, we're doing let's say every month, every 2 months, but it's usually actually 2 weeks to a month. We're going to do one increment, right? We do a little bit of everything. So we get a feel how long things take, right? We take one requirement, we implement it, then we go to increment two, we do another requirement, increment three, we do another one, right? And eventually we have a full project, but also the advantage of this is we get a good idea what we could get done in 3 years, right? As opposed to the waterfall where we didn't know what we could do. We never knew while we were doing the first two stages how long the development was going to take, right? But over here, we know because we're doing a little bit of everything. We're doing one increment a month. So this is, by the way, this is if you've ever heard of Agile or Scrum, right? This is all, this is all the iterative, they're all the same idea, right? That's what this is. This is called Agile, iterative programming, Scrum. Um, there's probably a lot of different terms for it, and also maybe different ways exactly how it's done. Okay, so we'll pick up on Thursday. Okay. Okay. Well, it works. So basically, this is chapter two. Okay. I'm gonna save these pictures. Okay. So see you on Thursday. Okay. I better plug in that machine. Well,
So on the,
okay, so let me just turn the recording.
I'm gonna be able to come into class, but I'll be able to log into Zoom on Thursday.